Hey guys, Travis Gillespie here. In the last video we were graphing inequalities, and now we're going to move forward from here. We're going to take a couple more steps, so let me get this information on the screen. We're actually going to solve inequalities and then graph them after that point. So let's pretend you're given the inequality 4 plus x is greater than or equal to 9, and I want to graph this inequality. Before I can graph it, I need to solve it. I need to isolate this variable x. So let's go ahead and change colors, and first thing I'm going to do is ask myself, how can I isolate x? Well, I need to get rid of 4. And I can see that 4 is being added to x. But I'm not really concerned about this addition symbol. That's not going to help me get rid of this 4. So in order to get rid of the 4, I'm going to circle the 4 and think about what operation is to the left of 4. Well, there isn't an operation. If there was, I would have circled it with the 4. Since there's no operation to the left here, and I know that this 4 is a positive number, I'm just going to plug a positive sign in here and think of this as positive 4. Now all I just have to do is ask myself, what's the inverse of positive 4? Well, the inverse would be negative 4. So negative 4 will help me undo positive 4. Remember, whatever I do to this side of the inequality, I've got to do to the other side. So whatever I do to this side, I've got to do it to the other. I'm subtracting 4 here. So I'm going to subtract 4 on this other side. Cool, I'm going to change colors again. The positive 4 and the negative 4 will cancel each other out. On this side of the inequality, I'm left with x is greater than or equal to, well, 9 minus 4 will give me 5. And now from this point, I can actually graph this information, this inequality, on the number line. So let's go ahead and do that real quick. And the values, I'm actually going to put some hash marks here, and the values I'll use are negative 10, negative 5, and on the other side I'll use positive 5 and positive 10. Alright, and I know I'm going to graph 5 on the number line, so I'm going to put a circle on positive 5. Since x can be any value that's greater than or equal to, I know that this circle needs to be shaded in because of that symbol. And then just ask, where are the values that are greater than 5? Well, the values that are greater than 5 are to the right of 5, so my arrow will move to the right. Now I can see that x can be greater than 5 or equal to 5. Okay, I can actually check this work to make sure that this is true, this solution's true. Okay, so in order to check the work, what I can do is substitute 5, my value 5, into x back in that original equation. So I have 4 plus 5 is greater than or equal to 9. Okay, so 4 plus 5 is 9, and 9 is greater than or equal to 9. Does this check out? Yeah, absolutely, it sure does. Cool stuff. So this actually checks out. So I'm going to move on to another problem. This time we have n minus 3 is less than or equal to 6. Alright, so in order to isolate n, I can see that n is being subtracted by 3. I want to circle 3, the term 3, and the operation to the left of it. So now I'm going to undo subtraction of 3, and the way I do that is by adding 3. The inverse is addition of 3. If I do it to this side, I've got to do it to the other side. And I can see that negative 3 and positive 3, or subtraction of 3 and addition of 3, cancel out. And now I'm left with n is less than or equal to, well, 6 plus 3 is 9. So n is less than or equal to 9, and I can graph this information. Alright, so we'll put a couple hash marks on this number line. Negative 10, negative 5, then 5, and 10. And I'm going to put my circle right before this 10 because n is less than or equal to 9. I'm looking for 9 on the number line. I'm going to put it right here, right before the 10, and then I'm going to shade it in because of that symbol. And I'm going to ask myself, in which directions are the values that are less than 9? Well, that's to the left of 9, so my arrow should move out to the left. And I actually want to make sure that I connect this arrow with my circle. Okay. So now I'm going to carry this all the way out and shade in my arrow, and now I can substitute 9 back into the original equation. So I have 9 minus 3 is less than or equal to 6. Well, 9 minus 3 is 6, so 6 is less than or equal to 6, and this checks out. Let's move on to another. Okay, so I put this inequality back up on the screen because I'm going to write one that's similar to it, but it's not the same. So 4 plus x is greater than 9. So let's go ahead and graph. Alright, and let's put a number line up on the screen. We'll get 0, and I'm going to put a couple hash marks here. And I'm going to use those same values as earlier, -10, -5, 5, and 10. Okay, so the overall goal is the same. It's to isolate this variable. I'm going to circle 4 and the operation to the left of it. Since there's not one, I'm going to treat it as a +4. I want to undo +4 here. Well, that's with a -4, so I'm going to undo it with a -4. If I do it to this side of the inequality, I've got to do it to the other side. So +4 and -4, they'll cancel out, and I am left with x is greater than, well, 9 minus 4, again, it's 5. So let's go ahead and graph this inequality. Alright, so I'm going to put my circle on the 5. I'm going to leave the circle open because of this inequality symbol being greater than 5. And I'm going to ask myself, in which direction are the numbers greater than 5? Well, they're to the right of this circle, so my graph, my arrow will move to the right of the circle on the graph. Alright, so just remember, this graph is telling us that x can be any value that's greater than 5, and it can get really close to 5. It could be, let's see, what's the next number past 5? Some of you might think 6. I'm going to put a 6 down, but it could also be any number in between 5 and 6. So it could be 5.1. It could actually be numbers that are between 5 and 5.1. So that's why we're using the open circle on the 5. It's saying that x can be any value close to 5, but not necessarily 5 itself. Okay, so let's move forward from here. I'm going to erase some of this information and ask yourself, how can you check this work? Well, earlier we substituted 5 in for x, but I'm not able to substitute this value 5 in for x this time. I cannot do this. So I'm going to undo this information, that arrow there, and ask myself, well, what values can be substituted in for x? Well, look at your graph. Is 5 a value on your graph for x? No, I'm using an open circle telling me that 5 is not a value for x, but x can be any value greater than 5. So all you have to do is choose a number on the graph that's greater than 5 and substitute it in for x. So let's use 10. Let's just substitute 10 in for x. So now I have 4 plus 10 is greater than 9. Alright, so 4 plus 10, well, that's 14. 14 is greater than 9. Therefore, this is a true statement. That means that I graphed it correctly, and the inequality x is greater than 5. This is also a true statement. Let's take a look at another. Alright, so this time, let's say you have 5b is less than 30. How can I isolate b? Well, I've got to undo multiplication of 5. So I'm going to divide both sides by 5. Multiplication of 5 and division of 5 cancel out. I'm left with b is less than 30 divided by 5 is 6. Alright. Okay, so going to the number line, we have 1, 2, 3, 4 hash marks, and I'm going to use -6, -3, +3, and +6. Okay, so I'm going to put my circle on the 6. I'm going to leave the circle open, and I know that b can be any value that's less than 6. So what direction are the values that are less than 6? Well, it's to the left of the circle. So I'm going to put my line on the circle and move out to the left on this number line and shade it in. Now, in order to check this work, what I'm going to do is I'm going to substitute a value that's on the line that's been graphed. So let's substitute -3. Let's plug that in for b. And now I'm going to change colors real quick. So now we have 5 times -3 is less than 30. Well, 5 times -3 gives a value of -15. And -15 is less than 30. This checks out. It's a true statement. And my graph, it's been accurately plotted. So the inequality b is less than 6 is a true statement. Cool stuff, guys. I'll see you in another video.